I know that the electric Vortech is really why many of you are here. But, you know, I had to get the car started. I had to get it running so we would have a test bed, if nothing else. You know, it's been parked for 2 years. There's been, you know, a lot of stuff going on, but finally got the thing running. And, you know, thankfully, everything worked out just fine. You'll notice in my last video, I referenced that there was the 75mm throttle body needed some work. As it turns out, I was wrong. The 75mm throttle body is not the restriction. The restriction turned out to be the Pro M elbow that I was using going into the throttle body. It actually necked down to 68mm, so smaller than the 75mm throttle body, right at the elbow, which is the worst place to neck down. Now that the car is all good, let's get back to the electric Vortech because we're almost there. I mean, we're talking, you know, maybe a week, 2 weeks tops before we can actually do some real tests. Now, I still have to drill the 6 bolt holes here, and I need to make a couple of Teflon washers and a couple of Teflon seals, actually, for the bearings because I figured out how to lubricate them, which brings me to my next point. I promise I'm not going to do this a whole lot, maybe just this once, we hope. I'm going to take a moment and shill for the Patreon account that I've set up to help pay for all this stuff. This is the first time I've been unemployed in 30 years, much less for 7 weeks straight. Even though we're deemed an essential business, we're still trying to figure out how to actually conduct business in a situation like this, but we're getting there. But anyway, this stuff is obviously expensive. This is the new electronic speed controller. You know, I mentioned, you know what? Here. I mentioned having to make some Teflon washers, and here's the Teflon rod. You know, that is a solid hunk of Teflon. How much, you know, something like that costs, I actually don't even remember, but you can bet it wasn't cheap. You know, and then there's this crazy grease that we found. By the way, I solved our lubrication issues with the addition of Kluber Lubrication's Isoflex NBU 15 grease. That's right, this 50-gram tube can be yours for the low price of $42. But this should actually allow us to more or less permanently lubricate the bearings, at least according to the engineers there. And hey, here's a nice little treat. It's made in the USA. Good job, fellas. If you find this information interesting, you know, and you're still lucky enough to be employed, you know, feel free to contribute a buck or two or whatever it is, even if it's a one-time deal to help offset the cost. Speaking of costs, I was supposed to have the battery packs delivered today, and, you know, that was something I was kicking down the pike because I didn't want to drop the coin. But, you know, I actually, they were supposed to be here today. They were supposed to be here at 9 o'clock, which is about an hour and a half ago. You know, I even have the connectors laid out. That's my little Vanna White move. The connectors laid out. And I was going to solder up some wires to the batteries, and we can do a true full-speed test today with the Sorcery. But unfortunately, Amazon let me down. You hear me, Jeff? You let me down. So what I decided I was going to do was do this whole experiment test, you know, tell you how this stuff works with the existing battery packs we had from the little DIY electric turbo, which was, you know, kind of nonsense, but it was fun anyway. It was a fun trip to the dyno. It's been a while. And so what I did is I took those 2 battery packs, they're over here, and I made an adaptation. I made an adapter cable. This is, what is this, 10 gauge wire that you see here, to put these 2 guys in series, which effectively doubles their voltage, or combines their voltage, I should say, since one is a 3-cell pack and the other one's a 4-cell pack. Anyway, so you have these 2 guys in series, giving us, instead of 12 cells, giving us 7 cells. So it's a little bit more than half, and it'll do because we're just free running this motor. So anyway, let me put these aside. And we have the electronic speed controller, the Sorcery that controls all of this. So what this is basically a 3-phase motor controller. So these motors are basically nothing more than 3-phase AC motors. So their speed is dependent on frequency effectively. You know, if you watch machining channels, you'll see a lot of variable frequency drives or VFDs being talked about and such. Well, this is kind of the same concept, if nothing else. And, you know, to give you guys a sense of perspective at home, these are 8 gauge cables, and there's 3 of them feeding this beast. So, you know, we should have some power. And, oh, this is another good aside. So Vortech has finally posted the compressor map for the blower that I have, which I have to send a thank you out to Vortech for doing that. I had called their engineering staff and asked them about it, and the guy said, literally said to me on the phone, there may be a hand-drawn one here somewhere. And lo and behold, here we are a few months later. I mean, you know, it took him a minute, but the guy was true to his word, and here's the compressor map. So now we have a good idea of what we're looking for, and depending on how much power it actually takes to spin the impeller, we're probably looking at anywhere from 600 to 750 boosted horsepower out of the engine. Now, I mentioned I'm glad we got that thing running, and we had data logs to look at from going wide open throttle. And, you know, we saw the restriction, but we also saw the duty cycle, and we were able to do a good calculation on what the power was. And that was with the restriction. I came up with approximately 502-ish crankshaft horsepower, which was a reasonable, maybe slightly pessimistic guess. Most likely the motor makes somewhere between 500 and 540 crank horsepower. So that's our starting point. So, you know, moving back to the sorcery, this is our electronic speed controller. So again, this thing basically generates a variable frequency voltage to the motor. It turns 2 windings on and 1 winding off every, you know, sort of control series or sequence. And that's how the thing spins. This happens to be a 6-pole motor. So I got this thing and I programmed it, and then I spent a while actually soldering on these 8mm bullet connectors, which RC guys use. And I have to say, I'm kind of digging the connectors. They're pretty cool. And, you know, I did some tests and it actually works. But I wanted to show you guys specifically how to control something like this. This ESC, or electronic speed controller, actually happens to be intended for a model airplane. I mean, this would be one Hulken model airplane, because this controller can handle up to 16 cells, not the 12 cells that we're running, but up to 16 cells and up to 400 amps. And this thing should be 300 amps at 12 cells. So there's some headroom in here. Basically, I wanted to minimize any losses going to the motor that I could. So these are obviously the control transistors, probably IBGTs or, you know, heavy duty MOSFETs or something under that particular heatsink. There's probably a microprocessor in this section. And here you have a bank of capacitors. I, to be completely honest with you, really don't know what they'd be for, but the bank of capacitors explain the need for this particular wire right here. This is an anti-spark cable, right? So it's disconnected, and the idea, there's a power resistor in line. You can kind of see it under the heat shrink tubing. But the idea with that thing is to charge up the bank of capacitors while limiting the current to prevent arcing. That tells you something about the power levels we're dealing with in what I consider to be basically a microscopic package, because we're talking about 15 kilowatts right here. The tankless water heater in my house is actually only 13 kilowatts, to put that in perspective. And that draws more power than anything else in the house. And this takes even more. So having said all that, you have this anti-spark cable. And the purpose of it, again, is to prevent arcing into these connectors here when you first power up the battery connectors. So I made mention of the actual battery thing that I concocted, which was this deal here. Let me move this stuff out of the way. Were these two batteries right here, and like I said, they're connected in series. So the way you would use the anti-spark cable would be, in my case, I attach 2 sets of connectors. One set of connectors is purely for anti-spark, and the next set is primarily for power. So when you first plug these battery packs in, what you have to do is you have to make contact with the top, the anti-spark, and I'll do that again, and I won't talk this time, so you can hear the ESC powering up. Now this is also really cool, I have to say. So when I was first learning about these RC electronic speed controllers, the way they communicate to you, if you don't use the USB port, and this one does have a USB port, and I've already programmed it, the way they communicate to you is through beeping sounds. But there's no speakers on the ESC. So the way they get the beeping sounds is actually through the coils in the motor. They use the motor as the actual speaker. That's kind of cool, I think. You know, so what they do is all those tones that you're going to hear actually come from the coils in the motor, and basically this ESC playing them like a musical instrument. So when you first plug it in, you know, there won't be a spark if you use the anti-spark connector first, and it'll charge up the capacitors, but it is enough power to activate the ESC. So here's what it sounds like. I'll do it one more time and get a little closer so you can hear it better. So now that the capacitors are basically charged, then you plug it into main power. Now the capacitors probably have a discharge resistor, or resistor as I would imagine, since it's a pretty, healthy bank. So I don't know how quickly they're going to discharge. So before I plug it into the main power harness, I'm going to plug it into the anti-spark harness. But what's the point in doing that if you can't control the controller? So let's look at that. This is actually kind of interesting. So RC protocol, if you will, you've heard of CAN bus on cars, where you can use basically two wires to communicate to a whole array of sensors and everything else without having, cabling running all over the place. This is kind of similar, but it's actually much simpler. So RC equipment, it's probably much simpler because it's been around for much longer. RC equipment basically runs on a 50 hertz sequence. So 50 hertz gives you 20 milliseconds between sequences or pulses, right? So they run between 1 millisecond and 2 millisecond pulses. So in other words, it's between 5% and 10%. And that's it. Now, I know this is not terribly clear, which is why I have visual aids, which is not a disease. Don't worry, I'm fine. Whatever. That might have been in bad taste. I'm not sure. Yeah, we'll see. It was a joke. Chill out. So anyway, in order to generate that, there's a number of devices that can do that. Obviously, if you have an RC transmitter and receiver, the receiver will actually output those things. They sell these really, really cheap little servo testers, which also do the same thing, and it's actually how we're going to control it. Plus, I just happen to have, sitting back in the equipment room I use for work, this control unit. Well, it was actually a focus and iris controller for the end of a jib, and as it turns out, it actually uses RC servos to move the gears on the lens. And I actually pulled that out at first thinking, hey, cool, it's a metal housing, it's got a battery and all this other stuff, I'll use that. What I found out about that was that its range was too much. So when I had it turned all the way down, the ESC would think a receiver wasn't connected to it. And this is kind of stressful in a good way, enough on the dyno and on the track where I don't have to be worrying about, where I don't want to be worrying about, where exactly the potentiometer is. So I decided to go with this thing. So where is this all going? And Jesus, shut up, guy. Well, this is a really cool opportunity to check out exactly how this stuff is controlled, and if you're following along at home, although I don't necessarily encourage that you do until we find out what happens here, plus there's a danger liability issue, so you know what, don't do it. But, there, it's been said. But anyway, this is how it will actually work and be controlled. So these higher powered ESCs tend to have what they call unpowered BECs, which is this little control number here. So what that means is on the lower end stuff, including the little DIY electric turbo guy that we dynoed on that Harley, there's actually voltage coming through this, and you don't need voltage going in. On these higher powered guys, probably because, the voltages are much higher and everything else, plus there's a noise issue to be had because these MOSFETs or, IBGTs or whatever they are in there, probably generate a fair amount of electronic noise that even this massive bank of capacitors can't filter out. It's probably not good to actually feed the voltage from the ESC to the controller. So they do it the other way around in these higher power units. So in other words, you have to feed a voltage in so the controller itself can operate and generate the waveform we talked about, and then go out to the ESC. So this guy needs 5 volts in, so what I did is I put it up to basically just a USB, power bank. And that's enough to make this little guy happy. So the other thing we're going to need here to check this stuff out properly is a little oscilloscope. Now I have a big one, but it's a little hard to video, and I'd have to actually stop what I'm doing. I couldn't do this necessarily in as close to real time as you're seeing it if I use the big guy. So I've got this little guy here, and it's actually a cool scope with the exception of it's very typical Chinesium in the sense that not only is the manual basically useless, but it is kind of sort of tricky to navigate and change things. Like right now, I can tell that this must be its default setting when I turn it on. The duty cycle is set to the wrong channel, so let me see if I can remember how to change the channel. So clearly that's not it. Let's go back to duty cycle, and then let's hit M. Maybe that'll do it. Oh, there we go. Source channel B, channel A. There we go. Okay, so we're good to go. So now the duty cycle is particularly important for us because remember the signal is from 1 to 2 milliseconds out of each 20 millisecond pulse, or 5 to 10%. So there we go. So let's start powering stuff up and take a look, see where we are. Fortunately, I happen to have an alligator clip handy because we shall need it. So I'm just going to clip onto the positive part of the probe. Now, the way the two battery or power sources interact is obviously they have to share a common ground, and that's so this ground passes through from here to the ESC. And then that way, at least, there's that 5-volt reference. So anyway, let me first power up the power bank. And what's interesting is that this control unit draws so little power that the power bank will not stay on. So I put in this little PCB LED just to put enough load on the power bank just to keep it on. So let me turn that guy on. The lights come on. My little sort of current draw sync, which, you know, kind of bothers me in a weird OCD way. It's like, you know, do I really need to be drawing power to whatever? Otherwise, this thing would last a lifetime on one charge. So what we have here now is a powered little servo controller. So let's hook it up. If you look closely to this amazingly cheesy plastic packaging, the way it's laid out is your grounds, and this can control up to 3 servos at once. So your grounds are all strung together right here. So I assume that that was smart. Oh, I didn't do anything to it. I just saw the light go out off to the side, and I thought maybe I shorted this or something because it kind of did sort of jerk it around a little bit. Maybe I did actually, and just safety on this thing kicked in. There we go. It's back on. All right. So now we have our ground connected. Let's see if we can. Our signal is actually the top set. So let's. We cannot touch the positive because otherwise the signal will just read 5 volts across the board. See if we can do this. I think we're good. All right. So I will have to punch in post here, but there you go. So you're looking at a frequency of around 50 hertz and a duty cycle of 4%, which is 1% below the threshold for an ESC to kick in and power the motor. So as I turn the potentiometer on the servo tester, the duty cycle starts to increase. And by this point, it's 7%. And remember, we only have to get to 10% to get full throttle. 8, 9. There you go. There's your 10%. So that's how that works. That's pretty cool, I think, that, you know, you go all the way back down. Let me go back down. So that's minimum throttle. That's maximum throttle. Now there's a couple other settings on this little servo tester. There's also a neutral and an auto, but frankly, don't care. So we won't even go into that because it doesn't apply to us. Eventually, I may do some kind of Arduino type solution to automate this process. But at this point, I mentioned that I programmed the ESC already. When you do that, I'm not going to go through that here unless there's like this massive outcry suddenly. We want to see how to program an ESC. Okay, well then I'll make a video. But right now I'm not going to. But this is basically a USB port, and you know the device came with a USB adapter. You plug it in, and you can set things like throttle acceleration, minimum starting power, things like that. And I found a nice happy balance. So one more hoo-ha on the knob here with the scope. Yeehaw. Less yeehaw. Actually, no yeehaw there. Yeehaw. No yeehaw. Okay, so that's how that's going to work. Now that you know what the signal is going into the ESC, this hopefully will clarify stuff like, wow, okay, I can actually see it. That's pretty cool. It makes sense now. So let's go ahead and, I don't know, let's unplug the scope first. We can probably very likely leave the servo controller powered up. Obviously, these things are polarity sensitive. So you know, but the cool thing is the way they laid these things out is if you actually swap the polarity, all you're doing is switching the ground and the signal and nothing happens. So that's pretty slick, and that's why I kind of went out of my way to find one of these connectors with the 3 positions instead of the individual ones, which I have a box of here, is because if I were to accidentally reverse this, I'm not going to harm anything because it's just going to feed the ground to the signal wire, and there's going to be no ground. So it's pretty smart the way that's laid out. So before we connect the battery to the ESC, we have to make sure that we get our BEC cable connected to the servo tester. So ground is on the bottom, so that's the brown wire here. The orange wire is the controller. So that's it. It's in, it's good. Now we just got to connect some batteries. So here are batteries, and again, I went through the whole spark arrestor, you know, anti-spark cable thing, so we'll do this. And we heard that. And by the way, those additional 2 notes were indicating that it sees a receiver connected, so that's a good sign. So now we'll just plug into the main power, and actually I heard a spark there, so note to self, you got to do that pretty quickly. All right, so we're ready to go. That beeping indicates that it's, you know, give her some gas. So let's go ahead and do just that. Let's go straight to, I'm going to move the motor directly under. Now I'm going to hold the motor in place because this thing's going to want to torque over, even though we're only running a little bit over half power here. So let's just hit our full gas. And that's it. It's just that simple. Picture it on the dyno. Mat it. Now, at one point, I was, with the light overhead not being these lights, I guess it has a flicker to it because I was having a hard time making sure this thing was actually rotating in the correct direction. With this ESC being one of the less expensive ones, but still, you know, I mean, you're talking about a 400 amp electronic speed controller. It still did cost something. I wasn't sure which direction this thing was spinning, so it's a lot of power, right? So I figured, okay, well, I'm not touching this because it's got the set screw flying around at 1 trillion RPM. I don't want to lacerate myself. So maybe what I'll do is on the back of the motor, you can see the shaft sticking through the bearing. I'll just kind of feel that as I wind it down. I put my thumb on that for like maybe 1 second, and the friction burn I got was unreal. It still hurts. That was like 2 days ago. So, you know, I mean, this thing is spinning. Now, at this voltage, it should be spinning enough to put us on that compressor map someplace, but we're not going to run it like this. The only thing left to do here, again, is the 6 bolts, the Teflon washers, and basically, you know, lubing up the bearings. Obviously, the bearings are right here, just off camera. Here's the new bearings. There's one of them. You know, we're going to slap this thing together, and I'll probably do a test at first because I am, you know, I just want to make sure the hex drive works, everything else works. So we're going to do that test maybe with these battery packs at first. But if I just go, instead of going full tilt, if I just go maybe, what, 1/4 of the way? So it's fairly calmly spinning there. I don't know what that is. I wish I did. As I mentioned, the fancier ESCs actually do output RPM through, they measure it through back EMF from the motor. That's a pretty cool trick, but 2 things. 1, those ESCs that did that were expensive, and 2, those ESCs that did that and were expensive couldn't handle the power that this guy can. So this thing is just happily kind of cruising along. The bearings actually make a surprising amount of noise, and I mentioned in another video how unimpressed I was with the bearings, so I may actually change those out at some point, especially once we start looking for more power. But, you know, for the time being, I guess they work. This thing is, you know, just cruising away. There's no warmth, but if I go to full tilt, that motor starts to get hot fast. By the way, I'm not going to do it in the video, but I already measured the current draw here. Even at full tilt with no load, you're looking at just under 7 amps at, you know, just over 25 volts. So here we go. See, with the other controller, I couldn't go all the way on the potentiometer because it would go past the range. This thing is just happily cooking away. I don't want to touch the shaft, that could hurt. It's starting to get a little bit warm, even under no load. So clearly this thing is going to require some significant cooling. You know, they do interestingly make water cooling jackets for them. So especially if this thing ends up being mounted in the engine compartment, that may be something we do down the road. One other thing, I mentioned the batteries. The reason why you see 4 connectors is that I decided to go with 3 4S packs for one, well, yeah, really one primary reason. There's sort of a secondary reason, but it's maybe tangential to this whole equation. So that's annoying. So the reason why I went with 3 4S packs instead of 2 6S packs, which is what really a 12S or 12 cell pack is, it's 2 6S packs. That's fun to say that fast. Be the delight of people at parties. Anyway, so I went with those because 4S is the largest cell count I could find where they sell chargers that are A, cheap and cheerful, and B, they just start charging. There's no, you know, computer interfacey stuff you have to do to get them going, you know, even if it's just touching, you know, 5 buttons or whatever it is. Because down the road, the idea is to have this stuff mounted inside the car and have it automatically recharge the batteries when you're not using the blower. So that should be a pretty cool trick, but that's down the road. We got to make sure this thing makes power first. So there you go. Subscribe.